Jai Hind students, after discussing stoichiometric defect, now we will discuss non-stoichiometric defect. Non-stoichiometric defect means imperfection in crystals are such that the ratio between cations and anions become different from molecular formula. It means after defect, change in ratio between the cation and anion. Suppose a crystal AB in which A cation and B anion. So after defect, maybe axis of cation or axis of anion. So this defect are two types. Number one, metal axis defect. In metal axis defects, this is also two types. By adding of extra cation or by creating anionic vacancy. By adding of extra cation. Look, this is a crystal, this cation, this anion, cation, anion. So listen, in this crystal, one cation enter into an interstitial site and one electron also enter in interstitial site. So electrical neutrality maintained of this crystal. Example, listen, when ZnO, zinc oxide, heated, it convert into zinc ion and release oxygen gas and 2 electrons. So look, when zinc oxide heated, it gives 2 zinc ions. It gives zinc ions and 2 electrons. So listen, cation, when suppose a crystal, this is a crystal, when crystal zinc oxide heated, so some zinc convert into zinc ions and these zinc ions enter into the crystal lattice. Look here, and these electron also enter in the interstitial site. So electrical neutrality maintained of this crystal. So such type of defect by adding of extra cation. White color zinc oxide convert into yellow color. So it gives the color. Now second type, by creating anionic vacancy. Listen, one of the anion missing from the site or crystal lattice and electron occupy the space of this anion. How can it happen? Listen, first anion missing from its position, then create a hole. Anion missing from its position, create a hole, then hole occupies an electron. This electron responsible for give the color of that crystal. This hole and occupy this electron, an electron responsible for giving the color of the crystal, this is known as epicenter. Epicenter means in general language, F means far away means color. So F represents far away and color. So this is known as epicenter. Look, example NaCl. When NaCl heated in vapors of sodium, so some sodium atom deposit on the surface of NaCl. Just imagine this is a crystal of NaCl. When heated in vapor of sodium, so some sodium atom stick on the surface of sodium chloride. And in this crystal, when sodium atom stick on the surface, so one chloride ion means one chloride ion. When NaCl heated, then chloride ion missing. Then chloride ion missing from this hole and create a hole. And this chloride ion react with Na, which Na deposit on the surface. first convert into anion, positive cation, and leave one electron. And this electron enter in this hole. And how can give color? Color. When we heated sodium chloride, so energy is released. So this electron gain energy and comes to the higher energy level, and then when come back in the ground level, ground state, then release that energy, and that energy if fall in visible region then give color. So NaCl give yellow color. Yellow color when when heated in presence of sodium. Second example, LiCl, lithium chloride. When lithium chloride heated in vapors of lithium, then missing of chloride ion and react with lithium ion, then release electron and give pink color. And in case of KCl, when KCl heated in vapors of potassium, it gives violet color. Violet color. So now we can say this crystal gain color after heating. Suppose sodium chloride heating in presence of sodium, it gives yellow color, and lithium chloride heated in presence of lithium, so it gives pink color, and KCl heated in presence of potassium vapors, it gives violet color. Okay, so now after discussing this metal axis defects, मेटल एक्सिस मीन्स यहाँ से एक एनाइन मिस हो गया, एनाइन मिस हो गया तो कैटाइन बचा. इट मीन्स एक एनाइन के मिस हो जाने से तो मेटल की तो एक्सिस हो गई ना, एक एनाइन तो निकल गया यहाँ से, तो क्या रह गया, यहाँ पे रह गया कैटाइन, और कैटाइन की एक्सिस हो गई, तो कैटाइन क्या है, मेटल है, एनाइन क्या है, नॉन मेटल है. तो जब कैटाइन यहाँ पर एक्स्ट्रा हो गया, सो वी कैन से एक्सिस ऑफ मेटल. हियर ऑल्सो व्हेन एक्स्ट्रा cation enter into the interstitial side, so axis of metal. So in both case we find axis of metal. Now second type, metal deficiency defect. In metal deficiency defect, one of the metal, listen, this is found in the transition element, those have variable oxidation state. Suppose two cations from here and from here, two cation missing, two cation missing from this side, leave their position, and one cation which having two positive charge, it means electrical neutrality maintained, because when one positive charge missing and enter one cation which having two positive charge, so electrical neutrality maintained. But here vacancy of metal, it means कि metal की क्या हुई, metal की deficiency हो गई. भाई एटम एक आया ना, तो एक तो होल रह गया ना, तो यहाँ पर क्या है, यहाँ पर कमी हो गई मेटल की. तो ये जो केस होते हैं ये जनरली ट्रांजिशन एलिमेंट के अंदर होते हैं. क्यों? क्योंकि ट्रांजिशन एलिमेंट में वेरिएबल ऑक्सीडेशन होने की वजह से, सपोज एक मेटल है, आयरन ही है सपोज, तो आयरन जो है अगर टू है एटम आयरन के, तो अगर आयरन किस स्टेट में पाया जाता है, आयरन 2 और 3 स्टेट में पाया जाता है. तो इसी तरह से कुछ एटम्स होते हैं जो कि 1 ऑक्सीडेशन स्टेट और 2 ऑक्सीडेशन स्टेट में पाए जाते हैं. तो अगर यहाँ पर कोई एक एटम ऐसा एंटर कर जाता है जिसकी 1 पॉजिटिव स्टेट है और वो हट करके 2 पॉजिटिव स्टेट वाला आ जाता है, तो उस कंडीशन में एटम तो आ गया लेकिन एक एटम की डेफिशिएंसी रह गई, पॉजिटिव चार्ज इलेक्ट्रिकल न्यूट्रलिटी मेंटेन कर ली, बट मेटल की डेफिशिएंसी है. सो दिस डिफेक्ट वी कैन से मेटल डेफिशिएंसी डिफेक्ट. इन दिस केस सपोज FeO, Fex मींस दिस इज X मींस कि Fe की क्या कंपोजिशन है, तो Fe की कंपोजिशन इसमें वेरी करती है 0.93 से लेकर के 0.96. सो नाउ we will discuss about the how can question come in CBSE board.